Hello student, welcome back. It is lecture 5 module 3 Microcontroller and Embedded System. Shongita Roy, Assistant Professor, Electronics and Communication Engineering Department, Narula Institute of Technology. (8051) Assembly Language Programming Tools. In the previous classes, we have completed 8051 Microcontroller Assembly Language Programming, the structure of 8051 Assembly Language, example, etc., time delay calculation, I/O programming. Today's class, call instruction in 8051 Microcontroller, how to calculate exact time delay in 8051 Microcontroller. The delay subroutine consists of two parts, setting a counter and creating a loop. I/O port programming in 8051. Lecture 5. Bit manipulation, input-output programming in 8051. Bit manipulation is a powerful feature of an 8051 ways of accessing the entire 8-bit data. Example 1. Let's examine an example in which the entire 8 bits of port 1 data are accessed. Back, move A #55H. Move P1, A call delay. Move A #0AAH. Move P1, A call delay, SJMP back. In the above example, the code toggles the every bit of port 1 continuously. This code can be written in a more efficient manner by accessing the port directly without going through the accumulator. So again find it. So back, move A, 55H. So accumulator value will be 55H. Accumulator value will be transferred to port 1. There will be a delay of AAH. Then the accumulator value will transfer to port 1. There will be another A call delay, SJMP back. So it will toggle the switch. Back, move P1, #55H, same program, it is more efficient. A call delay, move P1, #0AAH, A call delay, SJMP, more compact. This program is more compact than the previous one. Read, modify, write feature of an 8051. The 8051 port can be accessed by read, modify, write technique. This feature saves many lines of code by combining in a single instruction. The first action is reading the port. The second is modifying the port, and the third is writing to the port. Example, move P1 #55H. Load port 1 with 55H or 0101 0101 in binary. Again XRL P1 #0FFH, where E XOR port 1 with 11111111. Therefore, it is XORing the value with 0FFH. A call delay, wait, SJMP, repeat the action again. The code above first places the binary 01010101 to port 1. Then the instruction XRL P1 0FFH performs an XOR logic operation with port 1 with the binary number 11111111 and then writes the result back in port 1. XOR of 55H and FFH gives AAH, and the XOR of AAH and FFH gives 55H. Addressability of ports as single bit. This feature is used when it is needed to access only one or two bits of port instead of the entire 8 bit. Therefore, if we want to select bit by bit in a port, then this instruction will be helpful. This is a powerful feature of 8051, that the capability to access the single bit and individual bits of 8051 IO ports without altering the rest of the bits in that port. Example 3. Let's examine the code in which the code toggles the port bit P1.3 continuously. CPL P1.3 complements then addressability of ports as a single bit. So port 0, then port 1, then port 2, then port 3. And each port of 8 bit corresponding port bit D0, 1.0.0 it is D0, 0.1 it is D1, and correspondingly. So it is shown over there how the port bit and the corresponding bit port 1.3 until it becomes high. Then as P1.3 becomes P1.3 is equal to 1 means high. Move P1, A, copy the value in the accumulator, that is H1, ACTV P2.0, make set P2.0 high, CLR P2.0, make clear P2.0 low, that is too high to low. The instruction JNB P1.3 again mean jump to the target stays in the nuzlocke as instruct. Now, 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 now. Five and now compare the addressing modes of 8051 microcontroller. Code the 8051 assembly language instruction using each code addressing mode. Access RAM using various addressing modes. Access the special function registers. Manipulate the stack using direct addressing mode. Code 8051 addressing to instruction to manipulate a lookup table. There are various ways of addressing the data are called addressing modes. The CPU accesses data in various ways. The data could be in register or in memory. The data can be provided as an immediate value. The 8051 provides a total of 5 addressing modes: immediate addressing, register addressing, direct addressing, indirect register, indirect addressing, indexed addressing. Register and immediate addressing modes. Registered addressing mode. Registered addressing mode involves the use of register to hold the data to be manipulated. Move A, R1. Copy the contents of R1 into accumulator register A. Move R3, A. Copy the contents of accumulator A into register R3. Add A, R4. Add the content of R4 to the contents of accumulator A. Add A, R6. Add the content of R6 to accumulator A. Move R5, A. Add the content of accumulator A in R6. The source and the destination register destination, the source and the destination register must match in size. If using 8-bit source, the destination must also an 8-bit. Using 8-bit source and 16-bit destination will give an error. The instruction now move DPTR A will give an error as the source is an 8-bit and the destination is 18-bit register. Move DPTR #36E4H. Move R2 DPL. Move R3 allowed. The instruction move R2 R3 is invalid. Immediate addressing mode. The source operand is constant. In this addressing mode, the operand comes immediately after the opcode. In immediate addressing modes, when the instruction is the register addressing mode can be used to load information into any of the register, including the data pointer DPTR register. The data pointer DPTR register is a 16-bit register. The DPTR register can also be accessed as two 8-bit registers, DPH and DPL. DPH stands for data pointer high byte and DPL stands for data pointer low byte. Move A hash 24H. Load 24H into accumulator register A. Move R3 hash 255. Load the decimal value 255 into R3. Move B hash 55H. Load 55H into B register. Move DPTR hash 1234H. Load data pointer DPTR with decimal value 1234. Move DPTR hash 1234H. The above instruction is same as move DPL hash 34H, move DPH hash 12H. The maximum value that the data pointer DPTR holds is 65535 or FFFFH. If value loaded above 65535 will give an error, move DPTR hash 67000. This is illegal value as 67000 is greater than 65535, that is to FFFFH. It is prohibited. EQU directive. The equal directive is used to access immediate data. Counter EQU 20. Move R3 hash count. Load R3 register with 20 or R3 equal to 20. 20 is equal to 14H in hex. The move DPTR hash our data. DPTR is equal to 200H. After this ORG 200H data DB Canada. The immediate addressing mode can be used to send data to 8051 ports, that is move P2 hash AAH. This is a valid instruction. So we are ending today's session, and in the next day we will start lecture 6. So today's it is the references, and thank you. We are ending today's session.